So in this session we discuss the adiabatic process equation of state. As we have seen the equation of state for isothermal process, there we got PV equal to a constant. Now this being a very quick process, adiabatic process, we can obtain the equation of state in terms of pressure and volume as PV raised to gamma is a constant. As we don't require the derivation here, we are taking the equations directly. So pressure into volume raised to gamma is a constant, where gamma stands for adiabatic constant of the gas. Adiabatic constant of the gas, we could see. Okay? So, gamma equal to adiabatic constant of the gas. That constant depends on the nature of the gas. Monatomic gas, one value, diatomic, triatomic, like that it changes. Okay? So, this particular formula you get by heart, and from this we can obtain two more equations of state, because adiabatic process, as no heat energy is exchanged, therefore you can have the equations of state related to pressure and volume, pressure and temperature and volume. So depending upon the situations, these three equations you must be knowing, and how to apply and where to apply. You must be knowing it properly. So how to obtain the other two equations? Here pressure and volume is related. Now from this particular equation you can come to the other two. For example, suppose I consider the case PV equal to nu RT, the formula. It's basic gas equation. Then I take pressure P equal to mu RT by V. Now I take this pressure equation into this one so that I can have this pressure removed. So substituting for pressure into this, you get mu into RT divided by V into V raised to gamma as a constant, I could write. Okay. So here mu constant, R constant. Okay. Temperature is there. So mu and R are constant, and therefore I take this mu and R to the right hand side. So what I get is T by V into V raised to gamma equal to K divided by mu into R. Okay. Therefore, this can be written as T into V divided by V. I can take it as V raised to 1, and here V raised to gamma. So V raised to 1 into V raised to gamma means V raised to gamma. This V raised to 1, when it goes up, it comes as V raised to minus 1, and therefore equal to K divided by mu into R. Now this K divided by mu into R, the whole constant I could say, therefore I can rewrite this as T into V raised to gamma minus 1 is equal to a constant. So this right hand side represents only a constant. I am not talking about the magnitude of those things. It simply says right hand side is a constant. So this is the equation of state, which is relating the temperature, the absolute state, into volume of the system. So this is temperature volume equation of state. So method you understood from this part. We are taking what? The gas equation and substitute accordingly into that one to get it. Okay. Now the same way, if I proceed to find the relation between pressure and temperature, what I do here is, in this particular equation, I substitute it again. See, like this. I substitute for V equal to mu into RT divided by P. And take this particular V into this one. What I get is P into mu RT divided by P raised to gamma equal to a constant. And now mu r constant, so mu raised to gamma, r raised to gamma, you can take it to the right hand side. So what remains here is P into T by P raised to gamma equal to K divided by mu into R raised to gamma. So here mu and R constant, gamma is also constant, so right hand side the whole thing remains a constant, and therefore I get that equation written as P into T raised to gamma by P raised to gamma is a constant. So right hand side the whole thing I am taking it as a constant, as I told you. Therefore P raised to 1 minus gamma, because this P raised to gamma goes up as P raised to minus gamma. So together I can take it like this, into T raised to gamma is a constant. So I am getting a third equation, which is in terms of pressure and temperature, P raised to 1 minus gamma, T raised to gamma is a constant. So we have got three equations of state for adiabatic process. So depending upon the nature of the variations, which all quantities are involved, accordingly you choose the equation of state and finding the values. Okay. Now one more point from this part is that indicator diagram. So what is the shape of the indicator diagram for this? Let us see. If I take this particular equation, that is P B raised to gamma is a constant, because indicator diagram is a graph between pressure and volume. Therefore, I consider the pressure and volume equation here, V along x-axis and P along y-axis. So P into V raised to gamma, sudden expansion. So it is found to be like this. Alright. So adiabatic expansion, it is like this. If it is isothermal, it goes like this. This is isothermal expansion. And this is adiabatic, because the slope is a little more large. So to compare that, I have drawn this isothermal also here, just to compare how this adiabatic expansion is done. Okay, so that's V raised to gamma is coming like this, because gamma value is always greater than 1. So whichever the type of gas be, the nature of the gas be, the adiabatic constant for the gas is always going to be greater than 1. Therefore, the graph slope will be a little larger than what you say, that of the isothermal process. Okay. So adiabatic process is a very, very important process. Okay. So equation of states 3 and indicator diagram. These three are the main points to be noted for adiabatic process.